next question here then is 2019, question 1D. And it is the calculation part. So the first thing I'm just going to have a look at here and write down is my balanced equation. So I2 plus 2 S2032 minus goes to 2I minus plus S406 2 minus. Okay? And just underneath, which we will need in time, is that we have, and I'm not going to do anything really with it now, but I am going to just put down 4 moles S2032 minus is to 1 mole of O2. Okay, so we'll just leave that for a minute. Next then, what I'm going to do is I'm pretty much underneath my equation here, as I always do. I'm just going to write down what I know. So in this question, I am told that the sodium thiosulfate solution contained 3.1 grams, and that was per litre. On average, I'm told 6.0 centimetres cubed of this solution was required for complete reaction with 200 centimetres cubed of iodine. Then I'm asked to show by calculation that the dissolved oxygen levels were a threat to fish survival. So what I firstly need to do is the average number of moles of sodium thiosulfate in this titration. Okay, so I have 3.1 grams per litre. So the first thing I need to work out is my number of moles in this 3.1 grams. So mass in grams divided by my relative molecular mass, and I'm given the full formula for sodium thiosulfate. So it's Na2S2O3 by 5H2O. Okay, so 23 by 2 plus 32 by 2 plus 16 by 3 plus 5 by 18. Okay, that's 1 by 2, which is 2, plus oxygen, which is 16. So that's going to give me a total of 248. So now I know my mass in grams is 3.1 divided by 248, and that gives me an answer there of 0.0125 moles. Now, that's 0.0125 moles per litre, because that 3.1 gram, I'm told, was in a litre of solution in my question. So 0.125 moles in 1,000 centimetres cubed, and I'm asked to find the amount of sodium thiosulfate in my average titration. My average titration, I've worked out from my question, is 6.0. So that's all I need to do here, is work out the amount that's in 6. So 0.0125 multiplied by 6 divided by 1,000 gives me an answer for part 1 of 7.5 by 10 to the minus 5 moles. That's my answer to part A. Part 2 then, I'm asked the number of moles that released the I2 detected in each titration. Okay, so this is my number of moles of S2032 minus. And this is where it's important that I have this. Okay, so this was written in the question. So I'm going to set up my equation for part 2, which is S2032 minus, and I'm asked for the average number of moles of oxygen. Okay, so it's S2032 minus in a ratio with I2. And I'm told I have 4 moles of sodium thiosulfate for every 1 mole of oxygen. Okay? Happy enough with that? So then from that, what we're going to do is I've worked out I have 7.5 by 10 to the minus 4 moles. So I multiply by what I know, by 10 to the minus 5 moles, minus 5, multiply by 1, divided by 4, and that gives me 1.875 by 10 to the minus 5 moles. And that's my answer to part 2. Next then, I'm asked for part 3, the concentration of dissolved oxygen in the water in moles per litre. So I have 1.875 by 10 to the minus 5 moles. And I'm told that I had 200 centimetres cubed here, that 6.0 of this solution were required for complete reaction with 200 centimetres cubed portions of the iodine solution. Okay, so I have to use the 200 for that. So this is 200 centimetres cubed, and I'm asked to calculate it in moles per litre, which is 1,000 centimetres cubed. So 1.875 by 10 to the minus 5 multiplied by 1,000 divided by 200 gives me 9.375 by 10 to the minus 5 moles. That's my answer to part 3. The final part then, so just make sure you label it clearly, the concentration of dissolved oxygen in ppm. So I'm going to use moles equals mass in grams divided by my relative molecular mass, and it's my dissolved oxygen concentration. 16 by 2 gives 32. Number of moles, 9.375 by 10 to the minus 5 multiplied by 32 is going to give me a mass in grams of 3 by 10 to the minus 3 grams per litre. I'm asked for it in ppm, so I have to multiply that by 1,000 to convert it into grams per litre. So my answer for part IV is 3 ppm.